Storage and query. Overview of physical storage system. A database system provides an ultimate view of the stored data. However, data in the form of bits, bytes can get stored in different storage devices. There are three types of storage: primary storage, secondary storage, and tertiary storage. The storage that is directly accessible to the CPU comes under primary storage. CPU's RAM, fast memory, and main memory are examples of primary storage. Secondary storage includes memory devices that are not part of CPU, chipset, or motherboard. Magnetic disk, hard disk, and flash drives are examples of secondary storage. Tertiary storage is used to store huge volumes of data. Uh, these are external devices and are slowest in speed. Optical discs like DVDs and CDs and magnetic tapes are example of tertiary storage. Overview of physical storage system. The cache is the fastest and most costly form of storage. Cache memory is small. Is used by and managed by computer systems hardware. Main memory, the storage medium used for data that are available to be operated on, is main memory. The general purpose machine instructions operate on main memory. Although main memory can contain megabytes and even gigabytes of data in large server systems, it is generally small for storing the entire database. Flash memory, also known as electrically erasable programmable read-only memory. Flash memory differs from main memory in that data survive power failure. Reading data from flash memory takes less than 100 nanoseconds, which is roughly as fast as reading data from main memory. However, writing data to flash memory is more complicated because data once written can take about 10 to 4 to 10 microseconds that has been written already to overwrite the data. Drawback of flash memory is that it can support only limited number of page cycles ranging from 10,000 to 1 million. And flash memory has found popularity as replacement for magnetic disk or storing small volumes of data in low-cost computer systems. Magnetic disk. The primary medium for long-term online storage of data is magnetic disk. Usually, the entire database is stored on magnetic disk. Usually, the system must move from the data from the disk main memory so that they can be accessed. After the system have been performed their designated operations, the data that have been modified must be returned to the disk. Optical storage. The most popular forms of optical storage are the compact discs, which can hold about 640 megabytes of data, and digital video discs, which can hold 4.7 to 8.5 gigabytes of data per side of the disk. Data are stored optically on the disk and are read by laser. Tape storage. Tape storage is primarily for backup and archival data. Although magnetic tape is much cheaper than disk, access to data is much slower because the tape must be accessed sequentially from the victim. For this reason, tape storage is referred to as sequential access storage. In tutorials, this storage is referred as direct access storage because it is possible to read data from any location on the disk. Tapes have high capacity, 40 gigabytes to 300 gigabytes. Tapes are currently available and they can be removed from the tape drive, so they are well suited to cheap archival storage. RAID. RAID is redundant array of independent disks. It is a technology that connects multiple secondary storage devices and use them as storage media. A RAID consists of array of disks in which multiple disks are connected together to achieve end goals. And RAID level defines the use of disk arrays. A RAID consists of 7 levels. Uh, these 7 levels do not imply the hierarchical relationship and are different. Designate different design architectures that share three common characteristics. One, Set of physical drives viewed by the operating system as single logical drive. Data are distributed across the physical drives of an array in scheme known as striping. Redundant disk is used to store parity information which guarantees data recoverability in case of disk failure. RAID levels. Level 0 is striping. It is also known as redundant, and n disk the number of disks are available required. Uh, Small input, very high for both read and write. First level, next is mirroring. Uh, the number of disks required is 2n. It is higher than RAID 2, 3, 4, or 5 and lower than RAID 6. It is higher than single disk for read, similar to single disk for write. Second and third are parallel access, and the disk required are n plus m and n plus m respectively. The data availability is much higher than single disk and comparable to 4 and 5, 4 or 5. These are the transfer capacity is the highest of all the listed alternatives. Similarly, these are the next like independent access, which consists the level 4, 5, and 6. And the list required are n plus 1, n plus 2, and n plus 1 respectively. Database management system is software that allows access to data stored in database and provides an easy and effective method of defining the information, storing the information, and managing manipulating the information. It also provides the method to protect the information from crashes and theft, and also differentiates the access permissions for different users. Dbms acts as an interface between the user and the database, and the user requests the database to perform various tasks, operations such as insert, delete, update, and retrieval on the database. Modules for different functions. Some functions may be provided by the operating system. The database system is divided into two functional components: query processor and storage manager. Query processor help the database system simplify and facilitate access to data. The work of query processor is to execute the query successfully. It interprets the request received from the end user via an application program into instructions. It also executes the user request which is received from the TML compiler. Processor components. DDL interpreter. It interprets the DDL statements like the schema definition into the set of tables containing metadata stored in the data dictionary. DML compiler. It translates the DML statements like state, like select, insert, update, delete into a low-level instruction so that they can be executed. And embedded DML decompiler. It is the process of DML statements embedded in an application programming into procedural calls. Query evaluation engine. Execute the low-level instruction generated by the DML compiler. Second is storage manager. The storage manager is a program that provides an interface between the data stored in the database and the queries received. The storage manager is responsible for interaction with the file manager, and the raw data is stored on the disk using file system, which is usually provided by the conventional operating system. The storage manager translates the various DMS statements into low-level file system commands. Thus, it is responsible for updating, storing, deleting, and retrieving data from the database. It is also known as database control system, and it maintains the consistency and integrity of the database by applying the constraints and execute the DCL database. Storage management. Authorization manager and integrity manager. It checks the authority of users to access the data and checks the integrity constraints when the database is modified. Transaction manager. It ensures that the database remains in a consistent state despite system failures, and that the concurrent transaction execution proceeds without termination. File manager. It manages the allocation of space on the disk storage and the data structure used to represent information stored on disk. Buffer manager. It is responsible for fetching data from the disk storage into main memory and deciding what data to cache in main memory. Next is the storage. The storage manager implement the following data structures as the part of physical system implementation. Data files. It stores the database system. Data dictionary. It contains the information about the structure of the database, or it stores metadata about the database, in particular the schema of the database. Indices. It provides faster retrieval of data item. Statistical data. It stores statistical information about the data in the database. This information is used by the query to select efficient ways to execute the query. File structure. The file is a collection of records. Using a primary key, we can access those records. The type and frequency of access can be determined by the type of the file organization which is used for given set of records. File organization is a logical relationship among various records. This method defines how file records are mapped onto the disk blocks. File organization is used to describe the way in which the records are stored in terms of blocks, and the blocks are placed on the storage medium. File structure, sequential method. Sequential file method in this method, we store the record in the sequence that is one after the. Here, the record will be inserted in order in which they are inserted into the table. Sorted file method. In this method, the new record is always inserted at the file's end, and then it will sort the sequence in ascending or descending order. Sorting of the records is based on the primary key or any other. In this case, modification of the record, it will update the record and then sort the file. And lastly, the updated record is placed in the right place. Key file arrangement. It works with the data blocks. When the records are inserted, it doesn't require sorting and ordering of records. When the data block is full, the new record is stored in some other block. This new data block need not be selected from very next data block, but it will not be the next data block, but it can select any data block in the memory to store new records. Hash file organization uses computation of hash function on some fields of record. The hash function output determines the location of disk block where the records are to be placed. When the record has to be retrieved using the hash key column, then the address is generated and the whole record is retrieved using the record. B plus file organization. B plus tree file organization is an advanced method of index sequential access method. It uses tree-like structures to store records in the file. It uses same concept of key index where primary key is used to sort the record. For each primary key, the value of the index generated and mapped with the record. In this method, all the records are stored at the leaf node. Intermediate node acts as a pointer to the leaf node. They do not contain any records. Cluster file organization. When two records are stored in the same file in clusters, these files are known to have two or more tables in the same data block, and the key attributes which are used to map these tables together are stored on the guns. The cluster file organization is used when there is frequent need for joining the tables with the same condition. In this method, we are using insert. Delete and record data is sorted based on the key with which searching is done. Cluster key is type of key with which the lineage of the table is pulled. File structures. Type of cluster file organization. Index clusters, hash clusters. Indexing. Indexing is defined as data structures technique that allows you to quickly retrieve records from the database file. An index is a small table having only two columns. The first column comprises a copy of the primary or candidate key of the table, and the second column contains a set of pointers for holding the address of the second disk block where the specific key value is stored. Indexing attribute, standard B tree attribute. B tree is a type of tree data structure that contains only two things, namely index key and its corresponding disk values. Index key refers to a certain disk address, and that This further contains row and tuples of data. Bitmap indexing uses strings to store the address of the tuples or rows. Bitmap is a mapping from one another to the other, such as integers to bits. Types of indexes, single level index. It is somewhat like index found in the book. Index of a book contains topic names along with the page number. Similarly, the index of the table database contains key with the corresponding block. Primary indexing. Indexing or index table contain created using primary keys known as primary indexing. As the index comprises of primary key, they are unique, not null, and is one-to-one relationship with the metaphors. Characteristic of primary indexing. Search keys are unique. Search keys are in sorted order and they cannot be run as it points to the block of data, and also they are fast and efficient at searching. Primary indexing Dbms is also further divided into index, dense index, sparse index. In the dense index, uh, record is created for every search key value in the database. This helps you to search faster, but leaves no space to store index records. In this indexing, methods record contains search key value and points to the real record on the data. Secondary indexing. It is two-level indexing technique used to reduce the maximum size of the primary index. Secondary indexing is also known as non-clustered indexing. Characteristics of secondary indexing are search keys are a characteristic in candidate trees. Search keys are sorted, but actual data may or may not be sorted. It requires more time than primary indexing. Also, it is faster than clustered indexing, but overly cluster indexing. Cluster indexing is used when there are multiple records, mirror records found at one place. The most important thing to note here is that index table of clustered indexing is created into key values, which may or may not be unique. To achieve faster retrieval, we group the columns having similar characteristics, and the indexes are created using the groups and this is known as from clustering index. Let's assume that company recruited many employees in various departments. In this case, clustering indexing BBMS should be kept created for all employees who belong to the same department. Multi-level and similarly, there are multi-level indexing and BT index. The leaf nodes have themselves in the form of linked list. This linked list representation forms helps in the both sequential and random access. Suppose we have to search 55 in the above B plus 3 sector, we will fetch the intermediate node which will direct to the leaf node that can contain a record for 55. So intermediate node we will find the branch between TY and 75. Then at the end we will redirect it, will be redirected to the leaf node. Hashing technique. Hashing technique is used to calculate the direct location of the data recorded on the disk without index. In this technique, data is stored and the data blocks using address generated by using the hashing function. In this hash function can choose many of the column values to generate the address. Most of the time, the hash needs to be primary to generate the address of the data block. Very precision would mean the entire process or activity which involves query transition into code of exception, query optimization for save resources, cost estimation, or verification of next estimate. Parsing and translation. The fired queries undergo lexical, syntactic, and semantic analysis. The query gets broken down into different tokens and white spaces are removed along with the command. And synthetic analysis, the query was the first checks the query for the SQL has been correctly followed. Finally, the query procedure checks if the meaning of the query is right or not. And if the tables mentioned in the query are present in the data document. Query optimization. The next step, DBMS picks out the most efficient evaluation plan based on the cost each plan has. Aim here is to minimize the query evaluation time. The method also evaluates the usage of index present in the table and column. It also finds out the best order of queries to be executed so as to ensure only the best part of the plan get executed. Simply put, for a query, there are multiple evaluation paths to execute. Choosing one which costs the least is called query optimization. Execution plan query can be expressed in many ways. The query processor module at this stage using information collected in operation stage to find different condition of the tensor expressions that are equivalent and return the statement, one which will have the written under summary. Thank you.